All right, ready to dive deep. Today, it's all about fermium.
Fermium, huh?
Yeah, fermium. This synthetic element that's, well, kind of mysterious.
Definitely a bit of a mystery.
Super hard to make, disappears quickly, you know the drill.
Sounds right up our alley.
And we're going to figure out what makes it tick.
Sounds like a plan.
Using its Wikipedia page as our guide, of course.
All right, let's see what Wikipedia has to say.
So first things first.
First things first.
Fermium, it's not just some, lab creation.
Yeah.
It's connected to some major world events.
Oh, that's interesting. I like where this is going.
How many elements can you think of that are born from a hydrogen bomb?
I don't think I know of any.
From a hydrogen bomb blast.
You're kidding. That's how they found it.
That's how they first found it.
No way. You're pulling my leg.
I'm serious. Okay, tell me more. I'm all ears.
So we're talking about Ivy Mike.
Ivy Mike.
Yeah, the first hydrogen bomb detonation. Successful one, at least.
Whoa.
Scientists, they're looking through the fallout, right?
Yeah. I'd imagine there's quite a bit of fallout.
And bam, they find this brand new element.
Amazing.
And who do they name it after?
I wonder.
Enrico Fermi.
Of course.
Yeah.
Enrico Fermi, the nuclear physics legend.
Exactly. It's not just any scientist that gets that honor, you know?
That's got to be for a good reason. I mean, his work with nuclear fission must have been incredible.
Groundbreaking. Absolutely groundbreaking.
Okay, that makes sense.
It does.
But hold on.
What's up?
If it's made in a hydrogen bomb explosion,
Yeah.
doesn't that mean, it's just scattered everywhere?
Yeah.
How do scientists even get their hands on this stuff?
You're not going to find fermium just lying around.
That's what I was thinking.
It's synthetic. Got to make it, you know?
We have to make it.
We got to make it.
How do we do that?
We're talking high-tech nuclear reactor.
Nuclear reactors, huh?
Bombarding lighter elements with neutrons, like plutonium.
Wow.
It's a process that really pushes the limits.
I bet. That sounds way beyond anything I've ever done.
Oh, for sure.
But it makes you wonder, why go through all that trouble?
I know what you mean.
If it's so difficult to produce,
Yeah.
what's the point?
Right, what's the payoff?
What can we even do with fermium?
Well, the thing is,
Yeah.
right now, fermium doesn't really have any practical uses.
No practical use.
Not really, outside of research.
Interesting.
It's incredibly scarce, super
Yeah.
scarce,
Oh, cool.
and it vanishes so fast.
vanishes.
The most stable form, fermium-257,
Okay.
it has a half-life of about 100 days.
100 days. That's not very long.
Not very long at all,
So we can make it, but it's gone before we know it.
pretty much.
Gotta be frustrating for scientists.
Oh, absolutely. It's a challenge, big challenge.
But even if it doesn't stick around long,
Mm-hmm.
fermium gives us insights into how these heavy elements act.
It does. Valuable insights tells us about those super heavy elements.
So it's useful in that way.
Very useful.
Like, take the fermium gap.
Ah, yes, the fermium gap.
Scientists are having trouble making isotopes heavier than fermium-257.
It's like hitting a wall, you know?
Oh.
Shows us the limits of what we can do.
So even though we're not using it to build bridges or anything,
Not, yeah.
fermium is helping us understand physics and chemistry better.
Absolutely.
I like that, pushing boundaries.
Pushing boundaries. That's fermium.
You mentioned that fermium gap.
Bruh.
Why can't they make those heavier isotopes? What's stopping them?
It all comes down to stability.
Stability.
The heavier an element gets, the less stable
Interesting.
those heavier fermium isotopes.
Mm-hmm.
They undergo spontaneous fission, basically self-destruct,
Self-destruct.
before we can really study them.
Wow. So it's not just the half-life we're fighting.
No.
The element itself is fighting back.
In a way, yeah, it's a real challenge.
Okay, so we know about its origins, how it's made, and why it's mainly used for research for now.
So far, so good.
But what about its personality?
Personality.
Chemically speaking, what's going on at the atomic level? Ah, I see what you mean.
The Wikipedia article says it mostly exists as FM3 plus ions in solution.
That's right, like lots of heavier actinides.
Okay.
Fermium likes to be a +3 ion in solution.
Right.
But here's the interesting part.
Yeah.
It forms really strong bonds with some organic molecules.
Oh, so even though it's not very practical in the real world, it's got its own thing going on in the chemical world.
Exactly.
Tell me more about these bonds. What's happening there?
It's all about size.
Size.
Yeah, the FM3 plus ion, it's smaller than other actinide ions.
Okay.
It's because of its atomic structure.
Interesting.
This means it can get closer to those organic molecules, form those tight bonds.
So because of its size, it bonds in this unique way, makes those strong connections
You got it.
stronger than its neighbors on the periodic table.
Yes, definitely a key takeaway about its chemistry.
So it's not all just explosions and half-lives. There's some nuance there.
Lots of nuance. And there's even evidence it can exist as a +2 ion sometimes.
Yeah, it can form compounds like fermium-2 chloride.
So it can change things up depending on where it is.
That's right.
That's pretty neat.
It is, and it's all linked to where it sits on the periodic table.
Ah, I see.
If you compare fermium's behavior to other elements, like ytterbium,
Okay.
we start to see patterns
Pattern.
that help us understand the bigger picture of the elements.
The bigger picture. I like that.
It all connects in the end.
It's pretty amazing how we can learn so much from something so tiny and, well, temporary.
That's the beauty of chemistry, I guess.
It really makes you think about the power of these elements.
Absolutely.
Speaking of power, I have to ask,
Shoot.
is working with this stuff dangerous? I mean, it came from a nuclear explosion,
Yeah.
and we're talking about radioactivity here.
Right, so that's definitely a smart question.
So is it dangerous?
Okay, so fermium itself,
Mm-hmm.
it's not going to, like, explode on you or anything.
Okay, that's good to know.
But it is radioactive.
Radioactive.
All its isotopes are.
So that means,
It means they release particles and energy as they decay.
and that's bad.
It can be, yeah, it can be harmful.
Definitely not something to mess around with.
No, definitely not.
So how do scientists even work with it safely?
Researchers who work with fermium and other similar elements,
Okay.
they have to take serious precautions.
I bet. Like what?
Special labs,
Yeah.
sealed glove boxes, fume hoods, the works
To contain it.
to contain any radioactive material, yeah.
Smart.
Plus, there were protective gear.
I was going to ask about that. Like what kind of gear?
Gloves, respirators, that sort of thing.
To avoid getting contaminated.
Exactly. Got to stay safe.
It sounds intense, like being a scientist and an astronaut at the same time.
Kinda exploring the unknown, but with all those extra safety measures.
Makes sense.
Yeah, there's always some risk in research.
Of course.
But with radioactive elements, that risk is amplified.
For sure.
The key is to minimize those risks as much as possible.
How do they do that?
Careful planning, proper training, and the right equipment.
Sounds thorough.
It has to be.
And I guess the short half-life helps too, right?
It does.
It becomes less radioactive over time.
Absolutely. Fermium's decay.
Mm-hmm.
It means the radioactive material decreases rapidly.
That's gotta help.
It definitely helps reduce long-term exposure.
That makes sense.
But there's a catch.
Oh, what's the catch?
Those decay products,
Yeah.
they can also be radioactive.
So it's not just the fermium itself.
Yeah.
It's like its children too.
It's a chain reaction of caution.
A chain reaction. Wow.
So careful handling is still really important.
I bet. Gotta be extra cautious.
Always.
So scientists are always monitoring everything
Constantly, they're monitoring and adapting their procedures.
to keep everyone safe.
Everyone safe. That's the priority.
Well, it's incredible work they're doing.
It is.
With such a challenging element like fermium
It really shows how far we've come.
in understanding the universe.
Absolutely. We're constantly learning and pushing the boundaries.
And even if it doesn't have everyday uses right now,
The knowledge we get from studying it is super valuable
couldn't agree more. It's about expanding our understanding.
of matter and energy.
Exactly. And who knows what that could lead to in the future.
New breakthroughs, maybe.
Oh, definitely. New discoveries are always on the horizon.
That's exciting.
Very exciting.
Makes you wonder what's next for fermium research.
It does, doesn't it?
What are scientists hoping to do with it down the line?
Well, one of the biggest things
Yeah.
is creating those heavier isotopes.
The ones beyond that fermium gap.
Exactly. Pushing further into the unknown.
Ambitious. How are they planning to do that?
Scientists are always pushing the boundaries, right? They're looking at new techniques, new technologies,
Okay, like what?
particle accelerators, for example.
Particle accelerators.
They can smash atoms together at incredibly high speeds.
Flash atoms together.
Sometimes they fuse and bam, you've got a new element.
Heavier than anything we've seen before.
Potentially, yeah.
Wow, that's amazing.
It's like rewriting the periodic table. But why create these super heavy elements if they're so unstable?
That's the beauty of science. Sometimes we don't know what we'll find until we look.
It's about the journey.
It's about the journey, the exploration.
So creating heavier isotopes of fermium?
It could open up a whole new world of chemistry.
Like what?
New properties, new ways that atoms interact.
Things we haven't even imagined.
Exactly. The possibilities are endless.
It's mind-blowing to think about.
It is, isn't it?
All those secrets hidden in something so small.
The universe is full of surprises.
It really is.
It is.
But with all this talk about creating new elements,
Yeah.
it makes you wonder, is there an ethical side to this?
Ah, that's a good point.
I mean, we're manipulating nature at its core.
You're right. It's a question worth considering.
What do you think?
Anytime we push the boundaries of science, we need to think about the
The
consequences.
potential consequences.
Exactly. And with super heavy element research,
Yeah. Yeah.
Those consequences are mostly about safety and the potential for misuse.
That makes sense.
We don't want to create something we can't control.
Right. So checks and balances are important.
Very important. We need open discussions about the ethical implications.
So it's not just about what we can do.
It's about what we should do.
And it sounds like the scientific community is thinking about those ethical considerations.
Absolutely. Responsible innovation is key.
That's good to hear.
We have to be mindful of the impact of our discoveries.
And make sure we're using this knowledge for good.
For the betterment of humanity, that's the goal.
Definitely.
It's not just about blindly forging ahead.
We need to think about the bigger picture.
Always.
Okay, shifting gears a bit.
Sure.
I'm curious, what do you find most fascinating about fermium?
That's a good question.
What keeps you coming back to this element?
I think it's the mystery.
Mystery.
Fermium, it's like a puzzle with missing pieces.
A puzzle.
And every new discovery brings us closer to completing that puzzle.
The thrill of the unknown.
Exactly. That's what drives me.
And the possibility of finding something truly groundbreaking.
That's what keeps me going, that sense of wonder.
And it's contagious, I have to say.
Oh, yeah.
Even in a world that feels limited sometimes, there's still so much out there to discover.
I couldn't agree more. And fermium,
Yeah.
with its fleeting existence, its elusive nature,
It reminds us.
it reminds us that even in the most extreme environments,
There's always something new waiting.
always something new to learn, to explore.
It's amazing.
It is, isn't it?
So where do we go from here?
Where do we go?
What are some of the big questions about fermium that scientists are still trying to answer?
Well, there are a lot of unanswered questions about fermium.
Like what? Give me some example.
One of the biggest ones, can we stabilize those heavier isotopes? The ones beyond a fermium gap.
The ones that just disappear too quickly.
Exactly. If we could make them last longer,
Yeah.
who knows what we might find?
It's like they're teasing us, these elements.
They are. They really are.
Existing for just a moment.
A fleeting glimpse.
And then gone, taking their secrets with them.
If only we could hold on to them a little longer.
So how are scientists trying to do that? Stabilize them?
Well, there's some pretty amazing research happening right now.
Like what?
They're using these advanced cooling techniques
Cooling techniques.
to try and essentially freeze these isotopes in time.
Wow, freeze them in time. That's incredible.
It's cutting-edge stuff.
And that works?
Then we can study them properly, unlock their secrets.
What else are they trying?
Another idea is manipulating their nuclear structure.
Okay, how do you do that?
Maybe adding or subtracting particles, try to make them more stable.
So we're trying to outsmart nature, basically.
In a way, yeah.
Tweaking these atoms to behave differently.
We're trying to push the limits of what we know.
And if we can do that,
It would be huge.
a major breakthrough.
For chemistry, for physics, for all sorts of fields.
Okay, you've convinced me. I am officially hooked on fermium.
Glad to hear it.
It's rare, radioactive, hard to make.
It's got it all.
But it's teaching us so much about the universe.
It really is.
It's pushing those boundaries.
Always pushing those boundaries.
What a story.
It's a story that's still being written.
So what's the big takeaway here? What do you want our listeners to remember about fermium?
I think it's the idea
Yeah.
that even in the most extreme parts of the universe,
The parts we might overlook?
exactly, there's incredible beauty and complexity there.
Hidden beauty.
Fermium, it's tiny, fleeting.
But it tells a bigger story.
It shows us the vastness and mystery of the universe we live in.
I love that. Beautifully said.
Thank you.
It's a reminder that there's always more to learn
Always more to explore.
and that the pursuit of knowledge.
Is an adventure in itself.
So to all you deep divers out there,
Keep diving.
keep that sense of wonder alive.
Never stop questioning.
Who knows? Maybe one of you will make the next big discovery.
Maybe find a new element.
Wouldn't that be amazing?
It would.
Until next time.
Until next time.
Keep diving deep.